Hi, I'm Darren and welcome to Level Up EE Lab. In today's episode, I'll be repairing this Heathkit high voltage power supply. I'll give a brief summary of the background behind the internal construction and usage of this unique power supply, do my usual vintage vacuum tube instrument assessment, and plan out the repair and refurbishment scope of work. I've been patiently watching eBay for a few months to find a high voltage DC power supply. I wasn't being too particular, I just wanted something that had an adjustable regulated high voltage output, of course, and then also tube filament supply. Negative bias would have been a nice feature too, but really it's a little harder to find. And anyway, this Heathkit, or rather this Heathbuilt EUW-15 came up, and price was right. It looked to be in good cosmetic condition, and to make a long story short, I won it. Now, I don't really know, or didn't really know rather, that much about it at the time that I purchased it, so did the usual internet searching, and really all I could come up with was a schematic, and a few interesting clues also came up about its background. Here it is on my giant cake turntable. Its interfaces and controls are pretty straightforward. There are only 3 rotary controls, half a dozen 5-way binding posts, and 2 octal sockets. I'll go through the controls later. The binding posts are pretty much self-evident. They're where you connect jumper wires to get the filament and high voltage outputs. The octal sockets, on the other hand, are a bit odd by modern standards to find on a power supply. They're not there for vacuum tubes, they're for plugging in harnesses to a device under test. It was common back in the day to use an octal socket as a power supply interconnect. Its most interesting feature is under the hood. Looking here at the schematic, the high voltage circuit is not hardwired. It's been built to allow the user to manually reconfigure combinations of rectifier diodes, filter capacitors, and a choke. These dashed lines here represent jumper wires that can be moved around to join binding posts together. Depending on how you configure it, you can obtain half-wave rectified DC, full-wave rectified DC, various choke and capacitor filter networks, straight or double DC voltage, and varieties of regulated and unregulated voltage. Binding posts and jumper wires? Why on earth would Heathkit make such an odd power supply? Well, as it turns out, when I chased those clues that I mentioned earlier, this power supply was part of a series of instruments that Heathkit manufactured under the Heathbuilt name, specifically for use in a lab learning environment. In addition to the power supply, there was an oscilloscope, there were meters, and a whole bunch of other learning instruments, and these were intended to be used for students. The best source of detailed info on these Heathbuilt products comes from a book with the lengthy title, Electronics for Scientists, Principles and Experiments for Those Who Use Instruments, written by Malmstadt, Enke, and Toren, and first published 60 years ago. I was able to snag this used copy online pretty cheaply, and boy am I glad that I did. This is one of those times where you really do want to read the manual, and this book is invaluable for understanding this power supply. It contains multiple illustrations on how to configure the jumper wires for various architectures, depending of course on what type of rectification, filtering, and regulation you want the power supply to provide. Of course, this book isn't just about this power supply. Professors Malmstadt and Enke put together this book to teach practical electronics and test equipment knowledge, specifically to fellow scientists and lab engineers who needed to know how to properly use electronic measuring equipment. They conducted many classes in the 60s and 70s, and Heathkit manufactured this power supply along with other instruments in the EUW series, specifically for use during these classes. I also want to credit Rich Post, amateur call sign KB8TAD, for his article in the December 2019 issue of the Spectrum Monitor. I purchased a copy of that article, and it provided great info on his experiences refurbishing an EUW-15 and further reinforced the need to have the Malmstadt and Enke book. According to the U of I biography online about Professor Malmstadt, he retired in 1978, so that means I missed attending, or having the opportunity rather, to attend one of his classes there by about a decade when I was there as an undergrad. Now, beyond just the basics of how to use instrumentation for lab purposes and multimeters and power supplies. This book contains an enormous amount of good stuff on vacuum tube circuits and practical ways to design them, including this guy right here, a vacuum tube op amp. And now this design uses two 12AX7s, and those bad boys are still available brand new even today. I am really tempted to try to build this, but it needs plus 300 and minus 300 volts, and that would mean I'd have to build or buy yet another power supply. And I wonder, would this guy go rail to rail like a modern op amp would? Anyway, that's enough theory and background. Let's get into looking at the actual power supply. All right, let's take a closer look at the power supply, starting with the front panel. And cosmetically, it is in really nice shape. It's pretty clean and none of the graphics seem to be worn off. The actual controls, with the exception of the divider versus regulator select switch, seem to be working fine. This one is not turning easily, and as I've said before in prior videos, I'm not going to honk down on these old controls. You never know, something might really be stuck there and you end up breaking it. But the others, including the range selector, the potentiometer for the minimum to maximum voltage regulation, seem to be working fine. The two rocker switches at least are clicking and moving without binding. And each one of these 6 banana plug style 5-way function, whatever they are, posts, they're turning fine. So nothing's bound up there and nothing seems to be corroded, so that's good. Cosmetically, there is kind of a weird patina going on with the paint. In some cases it's a light beige in the back, but then it gets more yellowish along the sides. That might be nicotine from typical smoker's environment, or it just might be just thermal discoloration of the paint over time. I'll have to take a closer look at it. But yeah, nothing really to complain about cosmetically there. Now, a couple issues on the back panel that kind of stick out. One, obviously the rest of the power, the mains power fuse is missing, but that's an easy fix. More than likely that either got broken off or it got borrowed in the lab that this used to be in to get another piece of equipment running. But either way, easy fix. But a couple of subtle signs here. One is, move the cord out of the way. As you can see, there's a loose rivet here. So obviously it's not supposed to be loose. There's 2 other rivets down here that are tight. And then there's 2 missing fasteners here. Now, I don't know if those are screws that were taken out and not replaced, or if they're a couple of these rivets that fell out. But I'll find out shortly, because my next step is to pop the cover off and take a look inside the chassis. Okay, I've taken the cover off, and from this vantage point, I wonder if you guys can see a sign of what might be lurking inside. It's kind of subtle maybe with the perspective, but the transformer might look like it's a little tilted, and wah, wah, it's a lot tilted. So clearly something bad happened here, most likely during shipment. Now, when I got this a few months ago, the box was in nice condition. It was well packed, but nonetheless, it's still possible that this bad boy got dropped on this side at some point in transit, or maybe even before it got shipped. Who knows? But kind of telltale sign. It may not come through on the camera shot here, so maybe I'll put an inset in, but you can see just by the dirt and patina that's on the chassis, there are some very clean spots right around these bent tabs on the transformer. So it's more than likely this got bent during transit. So that's an issue. I don't think it's catastrophic, because looking at the primary and secondary side wiring coming out of the transformer, it looks like there was enough slack there for it to absorb that much deformation. So nothing looks like it got pulled to the point of straining those wires. The wires themselves, now since this is vintage early 1960s, insulation is maybe a little dry, but it doesn't. It's not that rubbery kind of insulation that gets really brittle and starts flaking off, and then you end up with a real problem. This seems to still be in pretty good shape, but I'll take a closer look at it. So continuing to look around, I'm going to spin over to this side, because you can see further evidence that it got dropped, again most likely during shipment, because all 3 tubes are kind of leaning towards the right here. So that's definitely not natural, and that's not terrible. I mean, they didn't fall out. I mean, best practice when you're shipping vintage gear that has vacuum tubes in it, the best practice is to pull these out and carefully pack those separately, just because you're not going to guarantee that they're going to arrive intact or worse, that they could break off and shatter inside of the unit. So removing these is generally best practice idea. But they seem to have survived, even though they're a little tilted. But I'll check them on the tube tester, all but the OB2. I can't check the voltage regulator on my tube tester, but we'll see if they're still good. Now, there's one other thing here, and hopefully it's coming through on camera. I think I'm going to redo the camera view to show this once, so we'll get a better view at it. Okay, so this shot will show my concern a little better. Somebody's done some rework here, and we've got this power resistor with a tap on it just sort of flopping in the breeze here. And it may be because this guy down here was no good and they just bent it out of the way. But nonetheless, not knowing what's going on here, classic example of why when you've got a strange piece of gear that you just purchased, whether it's a power supply, a radio, amplifier, whatever, it would be foolish just to trust it and plug it in and see what happens. You should always practice a little common sense, pop the cover off and have a look inside and see something like this that's highly suspicious. So might have had just some magic smoke from that alone, setting off something bad inside of here. Not even considering if the caps are any good, just something like that might have caused a catastrophe. So got to look at that against the schematic and see what's going on here. And then last thing I'd point out, this whole back panel is just kind of flopping in the breeze. There's supposed to be these two rivets I pointed out in the prior examination of the back panel. Those rivets or fasteners are missing, and the one that's loose is what helps tie that too. So this could have been additional shipping damage. I don't know, maybe when, if this did get dropped, in addition to bending the transformer, it might have popped this back panel loose. But at least this is an easy repair. I can put in some fasteners, of course, and get that tied back down, and then figure out from the schematic what's really supposed to be going on here and fix that and address it. And then one more quick item before I flip the chassis over and we look at the bottom side of it. The two selector switches. This one, is the one that is not rotating, and I don't see anything suspicious right away, but clearly on both of these, the contacts are corroded, they're oxidized, so definitely need to clean them up. And so I'll be careful trying to clean this one and see if I can get it freed up and working again. Okay, and here's the inside of the chassis with the bottom cover plate removed, and right off the bat, just looking at the general condition, nothing looks like it's smoked or scorched or otherwise burnt. The caps have not exploded, they're not leaking, none of the resistors look crisp, so maybe this had pretty gentle usage through its life. The other immediate observation is here is that quote-unquote programmable feature set that one can use to change the output configuration of the power supply. And these look like they're just little jumper leads with spring clips. Maybe use a pair of needle nose pliers to rearrange them. And on the bottom cover of the chassis, there's this little schematic to show how to arrange it for normal voltage doubler output operation. So I'll check and see if that's how it's hooked up. And of course, I'll look in that book and see what some of the other configurations look like as well. Not sure which way I want to use it yet, but I certainly want to try it out with the voltage regulator circuit first and make sure that it actually does provide good regulated high voltage. Other quick observations, the wiring looks fairly decent. I'm not sure if this was a factory unit though, because it looks suspiciously a little haphazard, but I will double check it like anything that you buy that is a kit or could have been a kit, or even anything that's had some service history. It's always a good idea to double check it against the schematic and make sure nothing is really squirrely there. So other than that, with trying to figure out how to use the programmable feature and checking out some of these resistors, there aren't that many of them, and of course figuring out a capacitor replacement plan, it looks like this is in pretty good shape. Setting aside the jumper wire complexity, the rest of the schematic and construction is really pretty simple. I pulled the 3 tubes and checked the 6BH6 and 6L6 on my Sencor tube tester, and they tested fine, no issues there. What I'm doing here is checking each of the 16 resistors to see if they've drifted beyond 10%, and they've also tested fine. Even this guy here that was cut out of the circuit tested fine, so I should be able to remove this adjustable power resistor and restore this section to original construction. While I had the tubes out, I also checked the primary and secondary taps on the power transformer and also the 5 Henry choke. All the windings have reasonable cold resistance values, so I don't suspect any problems with these components. Back to the stuck regulator divider rotary switch. After trying to twist it gently a few times, I concluded the shaft is seized inside the bushing. It's not moving at all. I've seen that before on Heathkit potentiometers. It's caused by aluminum on aluminum or steel on aluminum galling. I've not seen it before on a rotary switch, but that's my guess what's going on here. So I'll remove it and apply some heat to the shaft and the bushing. That frees it up most of the time. With all that done, I can finalize my scope of work for this project. First up will be a general cleaning, then replacement of the 8 electrolytic and film capacitors. For the larger electrolytics, I think I'll be able to tuck modern radial leaded ones under the chassis and disconnect and leave the original monsters in place just for show. Of course I gotta fix the stuck regulator divider rotary switch. And lastly, some punchless stuff like fixing the mains fuse, bending the transformer tabs back into position, checking the wiring for any connection errors, replacing the line cord with a polarized 3-prong cord, and fixing the floppy back panel. So that's a wrap for this episode. So what's up next? Well, I've got to order the replacement caps, and that'll take a few weeks for those to come in. But in the meantime, I'm obviously working on my HF receiver project, and I just got a bunch of those parts in today. So that'll keep me busy until I get the parts in for this power supply. And that's kind of how it goes on these projects. You got to have more than one going at a time because you kind of work on them in stages. It's like a hurry up and wait approach sometimes when you're waiting for parts and whatnot. So what'll be in the next episode? Well, I'll show the results of the repairs, check it out, make sure it's working to spec, and see if it's all good. So until next time, bye for now.